Okay, so welcome back. Now, let's write down some Trinket code, some Python code, sorry. So I'm just going to call this demo. We'll rename that. I'll call it demo. And now we can write some Python code, print hello world. This is how you write Python code, print hello world. So the print means Python, I want you to execute hello world. So I'm going to save that and then run the code. All right, great. So you can see the output, hello world. So all you see is the print. You see the print because you're telling Python to print out something. You won't see the print because print is just the keyword, okay? Telling Python to print something to the screen. All right, now we're not here to write hello world. We want to write some real Python code that animates stuff. So this is what we're going to be animating today. You can see that beautiful ball. It's sort of, you can see it, it's oscillating left and right. You see, this is what we're trying to create. We're trying to simulate this guy. And how do we do that? How do we do that? So you would see how to do that in this video, okay? All right, so the first thing we'll do is we'll create the wall. Oh, let's set the scene first, okay? Let's set the scene. So whenever I put a hash, hash means comment. So Python is not going to execute that code. So I'll just write scene setup. We're setting up the scene now. The next thing we'll do is we'll say scene dot auto scale equals false. So that means it doesn't scale automatically, right? We're setting the scale to how we want it to be. So scene.center, we want the center to be at the position 0, 0, 0. So scene.center equals vector 0, 0, 0. And then we want the range. We'll set the range. Scene.range equals 2. So if I run this code right now, nothing happens. Always remember to save your code. Okay, so I'll run it. Nothing happens basically because we've not printed anything. We're just setting up the scene. We want the position, the center to be at the vector location 0, 0, 0. So x is 0, y is 0, z is 0. Now let's define some constants. Let's define the constants. The spring constant k, would call that k is equal to 10, and it's the spring constant in newtons per meter. So you have the spring, I'll put a comment. This is the spring constant in newtons per meter, okay? Next, we'll define the mass. So the mass equals 1 kilogram. Mass in kilogram, comment, mass in kilogram. Then we want the length, the relaxed length, that's the natural length of the spring. So the natural length of the spring, that would be equal to 1 meters. Again, I forgot to put the comment. 1 meter. Now, here's where it gets interesting because you're going to be printing out stuff on the screen. It gets very interesting at this point. So if I run the code, again, nothing would happen. There's no visualizations. So here's where it gets interesting. Let's define the objects. We'll create a wall where the mass can oscillate. So wall equals, and I want this wall to be a box. Run the code. What do you think would happen? Oh, great. This gives me a box. You can see the box on the left. Ah, look at that. It's a 3D box. I can rotate it however I want. Now, if you want to rotate this box, if you're following this tutorial, you have to right click and then move your mouse around like that. If you left click, it's not gonna work. So now we have the box, but this box, we don't want the spring to be attached to that kind of box, right? And the box is not even white. That's not what we want. Here's what we want. We want the wall to be some small blue like that, okay? So how do we do that? Well, first we'll reduce the length, the size, and then we'll define the position. So we'll say position vector, position equals vector, -1, 0, 0, and this would set it at the position -1. Run the code. What would happen? Look at that. It now moves a little bit slightly to the left. Then we'll change the length. So comma, the length equals 0.05. So I'll give the length to be 0.05. So what do you think would happen? Oh, look at that. The box got smaller, right? Ah, okay. So let me rotate that and see what it looks like. But this is not quite like the box we have. All right. So I've changed the length. The length is 0.05. What else can we do? Let's change the height. So the height equals 0.5. This is not that interesting. You won't see that much of a change. Run the code. What would happen? Let's see. Oh, you can see it got smaller. Okay, great. Next, let's change the width of the box. The width of the box, width equals 0.5. Run the code. I forgot to save. Let me save it. Okay, great. Here's our box. And then, so that is looking like the box we have, right? Next thing we have to do is change the color. The color is blue. So can you guess the code? Can you guess the code? What do you think the code would be? Color equals color.blue. Run the code. Okay, great. Now we have the tiny little blue wall that you see there. You see that? Okay, great. Next, let's create the spring. So to create the spring, you'll say spring equals helix, and then you give it spring equals helix. Basically, let's see what that does. You can see that ginormous spring. We don't want the spring to be this ginormous, so we have to make it small. Our spring was not that big, so spring equals helix. That gives you a spring. Let's define the position vector. Position equals vector 0.5. Well, let's start with 0, 0, 0, 0, 0, 0. So what happens? Run the code. Okay, nothing happens. Next, we'll change the radius of the spring. So radius equals 0.2. Run the code. Oh, the spring looks smaller now, but it's far away from the box. So I don't want it to be far away from the box. So I'm going to change the thickness. A radius is 0.1. Let me give this radius of 0.1, and then the thickness, I would give the thickness to be equal to 0.03. Then color equals color.white. Great. Run the code. What happens? Thickness on number. I got it. I got an error. Near line 15. So let's correct that error. Oh, sorry about that. Oh, okay, I've seen the error. There's a okay, great. There's a dot there and I didn't put the dot. So all right, I think that should work now. Oh, great, great, great. So there was a comma, there was a dot after the 0.1, and then I was not supposed to put a dot, it's a comma because I'm separating the variables. Next, let's fix a mass to that wall, right? So mass equals sphere. Run the code. Oh, look at that sphere. Sphere is very big. So we don't want the sphere to be that big. We need to make it a bit smaller. So I'll say position equals vector. Actually, take a look at this helix. Let me comment out this line of code. Okay, let me comment out this line of code and let's run it. So the mass goes, but I put the position vector here. When I put the position vector here, I notice that the helix is far away from the wall. So I want the helix and the wall to be together, right? So what will I do? I'll append the helix position, that's the spring, to the wall. So I'll say POS equals wall.POS. POS, that's the position of the wall, is equal to wall.POS position. So it's gonna, you'll see this, the helix would move to the wall right now. Great, look at that. So the wall and the helix, they are connected. So we'll continue this video in the next, we'll continue this lesson in the next video.